So now it's your turn. So I would be happy to listen to your presentations. I would say, team one, if you are ready,
Yes.
just go for the presentations.
So I'll share my screen. Can you all see the full slide? So not
Yes.
presentation mode, but full slide.
Yes, I am seeing your slide, team one, and your names.
Okay. Yeah, so welcome to our presentation. So our team consisted of Julia, Victoria, and myself. Julia has a computer science background, Victoria electrical engineering, and I'm a bit in between embedded systems with systems and control specialization. So we worked together and came up with this communication structure. So in the front, you have vehicle 7, then vehicle 5. Well, I guess you all know it by now. With vehicle 7 having priority 1, 2, 3, 4, 5. And the basic communication is between the vehicles. So only having communication with the vehicle in front of you. But we also added communication from vehicle 1 to the other vehicles. And we created a different reader, DDS data reader for that one. And by filtering on the content of the topic, we could select these messages and separate them. And we did that because we wanted to, I mean, if vehicle 2 gets a half a meter from vehicle 1, okay, that's not a good example. When vehicle 3 gets the reference of that it needs to be half a meter behind vehicle 2, but vehicle 2 is not half a meter behind vehicle the leader, then we thought this one should ideally have a reference of being 1 meter behind the leader, despite the location of the second vehicle in the row. So that's why we decided to add this communication layer. And given that we are working with a relatively small amount of vehicles, that works well. If you're working with a very large group, then I would suggest to only use this. Just short, the references and constraints for the different vehicles. So we made a difference in the leader vehicle and the follower vehicles. For the leader vehicle, we just gave a reference velocity with minimum constraints and maximum constraints of minus and plus infinity. And important to notice that the weighting matrix in the optimization or objective function is 0. The elements are 0 for these positions. So we only are interested in the reference velocity for the leader vehicle. For the follower vehicles, we have the following reference. So we have the vehicle in front of you minus, oh, sorry, this is a mistake. Sorry. This should be the leader vehicle, this one, over the prediction horizon for the positions minus, the number of the ith vehicle that you are in the group to have a proper reference with respect to the leader vehicle. And we also give a reference velocity for the velocity. We put a y min of all zeros, but it could also be the same as the leader vehicle. And for y max, here we specify that we should have at least 0.3 meters distance from the vehicle in front of you, with the same maximum constraint on the velocity as for the leader vehicle. To show you the simulation results, these are the simulation results. So as you can see, after around 8 seconds, the vehicles are arrived at the correct platoon formation, and the signals get a bit more off the reference when we enter higher velocities, which I think can be expected. This is the velocity profile. So they converge with it via second order system to the references. The acceleration over time for the simulation. And I want to show you the video of the simulation that we did. So with vehicles 1, 2, 3, 5, and 7. So as you could see, at the different velocities, different reference velocities for the leader vehicle, the other vehicles could follow. And this is for 5 vehicles, but we have written the algorithm such a way that we can also extend with more vehicles. And one weird thing that I saw is that at the end of the simulation, the vehicles drove a bit backwards, and I tried to fix this issue in the code by not allowing negative inputs, but didn't work, and I don't know exactly what the solution is for that. Then moving on to the experiment. This is the graph for the experiment. It's a bit more, yeah, the signals are a bit more off of the reference. And honestly, I don't know where this behavior is coming from. Oh. So that's 0.1 meter off as a maximum of the reference that they get. This is the output velocity of all the vehicles. So it's also a bit more shaky, but still it converges towards the reference. And the acceleration profile, which is a bit more spiky than in simulation, but still, yeah. They satisfy the constraints. So now I want to show you the experiment video. A special thing in the simulation or in the video that I wanted to point out. I think it's in this corner where you see vehicle 3 having a bit of a fluctuating position between vehicle 2 and 4. You can see it's approaches vehicle 2 and then it goes a bit backwards. So we could maybe tune the weighting matrix a bit more towards position or reference control instead of following the reference velocity. But yeah, that's the video of the experiment. That's what we want to show.
Yeah, it looks very nice. Maybe I'll start with 2 comments. The first one is on the communication. If you would share your slide again.
Oh, yes.
Yeah, the next slide. Yes. Yeah, just a small correction. You said here, because the number of the vehicles is limited, we could communicate from the leader to the other vehicles. And if the number of the vehicles gets larger, then you would suggest to not use these additional links. Actually, using these links is very smart, because if the number of the vehicles increase, the whole system gets unstable if if we have just communications to the preceding vehicle. And we call this in automotive string stability of platooning, if you want to learn more about it. So the string stability depends on also on the communication structure.
Yeah, so maybe to make it, I mean, that's maybe a question, because if you really make the group large and you drive with trucks in reality, you have to deal with the larger communication delays, right? So if you communicate from vehicle 1 to, I don't know, vehicle 20 or maybe more, then maybe you should have in between stops for the communication in order to be able to at least reach the back of the formation. Is that correct?
Yes, you're right. There are people did and still doing their thesis about how to communicate inside a platoon to get it stable. And you find in literature papers about this and that communication structure, which is proven to be string stable. But what you have shown, I assume it is string stable.
Okay.
The next comment is on simulations and experiments. Just show any plot of experiments. You may show maybe velocity or acceleration. So it is totally fine in reality to have such jerky signals, because some of it is the nature. So in nature, especially the acceleration is changes a lot, and it's also due to the measurement system. So in simulation, the measurement is perfect, but in reality, maybe if you have the opportunity in your lab to see the signals of IMU, I mean, you can buy an IMU in the internet for some euros and get the signals out. You can see that you cannot see anything. So you have to use filters and to try to interpret the signals. So it's very, very natural to have such signals. Yeah, your simulation and your experiment worked very, very well. So thank you very much. I would open the floor for further questions from the audience.
Hi, hello. I would like to ask about the communication in the first slide. Having also serial communication means that the last agent is going to have a bit more delay until he gets all the other optimizations solved, basically. So what is the advantage of having also the this parallel computation on the top? Because I mean that agent 5, even if he gets information from the first agent, he still has to wait for all the rest to finish.
You mean, that's a question to me, right?
Yeah, yes.
So vehicle 5 has lowest priority, so should always wait until vehicle 4 has, vehicle 1 should always wait until vehicle 2 has calculated its prediction horizon. So, and you need this, we use this communication link to ensure the constraint of a minimum distance of 0.3 meter. And we use this communication link to be able to follow the leader with a proper reference. So this will be 1, 2, 3, 4 times 1.5 meter, which means this vehicle gets a reference of 2 meters behind the leader vehicle. Does that answer your question?
Yes. Okay. Thank you.
Yeah, maybe additional remark on this. This communication from the leader to, for example, vehicle 5 can be seen as a plan or a feed forward additionally to our feed forward in our MPC. So more information in the prediction.
I want to ask you a question, Dennis.
Yes.
I wondered the part related with the vehicles which follow the highest priority vehicles. I mean, by creating the MPC object, output of the maximum value of the output by max, you chose to define it as y prediction minus v ref, which equals to 0.5. I mean, in while coding this y max I matrix, while coding this in MATLAB, how did you implement it? Did you create while in the while loop, in the control loop, did you create at each sampling time an individual MPC object, or if you created MPC objects before the control loop begins, how did you implement it using a variable which is not defined at that moment? I mean, by prediction.
Yeah. So you mean, why is this y max time dependent in that sense?
Yeah. How did
Yeah,
you
that's-
implement it while coding in the MATLAB? I mean, you don't have the values of the y prediction at the beginning. This is what I want to ask.
Yeah, I guess I understand your question, and this is exactly the question I was also facing in the beginning until we also discussed with another group. But the model predictive class has a step function which allows for two different kinds of inputs. So you have the possibility to include your measurements and a reference, but you also have the possibility to include your measurements, your reference, y min and y max. So then using that second option, the class overrides the y min and y max that were initialized in the beginning.
Okay. Thank you.
Does that answer your question?
Yeah, thanks.
Okay, thanks.
It seems that there are no further questions. So thank you very much, Dennis. Thank you very much to Team 1. So impressive results. I want to ask everybody here, maybe we will not finish at 1, and if you are okay with just staying here till we finish, maybe you can get some snacks to not fall down. Okay, now I would ask Team 2 to share the screen and show their results.
Yeah, so we are Team 2, Antonello and Michelle. I guess we can just go directly to the graph. So yeah, basically we had similar, but we didn't have the communication link between the leader of the platoon to every platoon member. But yeah, I agree that it's a good thing to do, but we just choose a simple approach here. So the communication is just between the preceding vehicle and ego vehicle here, and then yeah, the priority is set like from the leader, and then just proceed all the way to the end of the platoon. And then yeah, we didn't do any slides for explaining the state or the objective function, but it's kind of similar. Like we have the for each vehicle, we just have the state as distance traveled and the velocity, and then for the leader vehicle, then we as Team 1 did, we didn't add any weight on the distance traveled, just for the velocity. And then for all the following vehicles, we have weight on that, and then the reference is basically the distance traveled of the preceding vehicle minus the desired distance kept between them. Yeah, and plus the velocity, the desired velocity profiles. Yeah, and then that's our result from the experiment. It looks, I think, almost the same as the first team here. Also, I get some, at the end of the result, we have something like due to perhaps measurement errors and other things here. But yeah, all of them converge to the desired distance here. Same for the velocity. Here you see how they follow the velocity profile. And here we have the input, the acceleration over time. And then just to play the video of the experiment.
Ciao, may you repeat the video because we lost the connection to you and we did see the beginning.
Yeah, my connection is not really good. Let me. Should I replay from the beginning or maybe something?
Yes, here is good.
Yeah, so here they started to move. Yeah, that's it.
Yeah, thank you very much. Looks nice. Could you go to the slide with the velocity plots?
Yeah, this one?
Yeah. Could you say something about the dynamics if I'm looking at a black screen? Okay, now again, it's working. Could you say something about the dynamics here? Could we get the vehicles, for example, faster?
What do you mean, like if I can get to
If we can get to the reference faster?
Oh, you mean here, like?
For example, yeah, at each step.
Yeah, I'm not sure.
Can I answer that maybe?
Yeah, of course.
For sure. I don't know. In my opinion, we could because we have this preview. And if we had a longer preview time, maybe the vehicle would accelerate sooner to the reference. And of course, if we increase the constraint. But around 15 seconds, you see that it starts accelerating sooner than that. And if we increase the preview even more, maybe it would start even sooner.
Yeah. So this dynamics here depends also on the vehicle dynamics, depends on the prediction horizon, of course. Maybe longer prediction horizons not necessarily lead to faster dynamics. They may lead to slower dynamics if they are too long. You could imagine, right? And the weighting matrices are also here important.
Yeah, exactly. I mean, you have this balance between tracking the velocity and the distance here. And then also the vehicle model itself. I mean, you can't just ideally follow the step anyway. It's you have the vehicle dynamic which restrict your performance.
Yeah, it looks very good to me. The floor is open for questions. So if you have questions to Chao, I mean in general to Team 2, please feel free.
Any more questions? I mean, I guess we just choose to do the simplest possible approach here. So
yeah, but it works.
Yeah.
Yeah. So there are no questions. Seems like this. Team 3. So now Team 2, sorry.
Yeah.
So now I would like to ask Team 3 to share their screen, and the floor is yours.
Do you see my screen?
Yes.
Okay, so we're Team 3, composed of Joseph and I. I present the graph structure. So we're basically we have the 5 vehicles, and the priority goes to the first vehicle, vehicle 7. And the vehicles are sharing their predicted distance. Okay, so since each vehicle has its own MPC and has its own model, we have to adapt and the output is the distance traveled S and the speed V. We adapted the reference as follows. So for the reference, for the distance, it should be the difference between the predicted distance of the previous vehicle and the distance of the reference vehicle. So here the leader does not have a previous, does not have a leader. So the first vehicle does not have a leader, and the last vehicle does not have a follower. So for the first vehicle, this would be its own predicted distance. And for the limits, well, the maximum distance would be the difference between the predicted distance of the leader and the minimal distance. And for the we have a maximum velocity. And for the results, Joseph will continue.
Yes, so apologies for the graphs. We couldn't quite redo them. I mean, couldn't redo the real life experiments. So as you can see, it works quite well in simulation. It doesn't work quite well in the real life experiment. Basically what happens is the DMPC for some of the vehicles fails multiple times. That's why it suddenly stops. Also in the real life experiment, the order of the vehicle seems to be reversed, so they converge to -0.5 instead of 0.5. Okay, next slide. So yeah, here we have the velocities. Once again, we can see that it works quite well in the simulation. doesn't work quite well. So in the experiment, we can see that at the instances where the MPC fails, the vehicles basically reset to zero. So that's why there are those spikes. Okay, next slide, please. Yeah, here we have, okay, so the output velocity, it looks quite similar to the input. Once again, we have these negative spikes. And the acceleration, once again, the same issue. Yeah, here we have also the acceleration of the actual or the output velocity as well. We only calculated it for the simulation because it's not in the plot platooning script. We did this ourselves. So yes, here we have the simulation. And as you can see, the vehicles form the platoon quite well. And now after distance, they will start accelerating. There. Then, yes, they start slowing down and eventually they should stop at the bottom. And once again, we will have this unwanted behavior when they actually start reversing. Yeah, it only happens in the simulation for some strange reason. Now we will look at the real life experiment. So here you will see that the vehicle 3, well, the main MPC for vehicle 3 fails, so it stops. But eventually the platoon is formed. And again, they start accelerating. And here the MPC for the last vehicle fails. And basically, yeah, I think what happens is that the output velocity goes over the limit, so the vehicle starts braking. However, it will reach the platoon eventually. Okay, so let's look at the possible results. Why the experiment ended up so badly. So yes, we could tune the matrices more specifically. Yeah, we could increase the penalty for the velocity because we did it in the simulation so that the distance following is as best as possible. But yeah, the velocity penalization in a certain sense works as a damping that kind of mitigates the differences between the model or between the simulation and between the actual physical system. So in this case, we could improve the behavior in the real life experiment by increasing the penalization of the velocity. Or we could also introduce the soft constraints using the slack variable. And yes, as I mentioned, the unwanted behavior when the vehicles reverse. So that is all from us. And thank you for your attention.
Yeah, thank you very much. So you said it looks bad, but actually it looks good. So don't feel bad. So just the last vehicle was a little bit crazy, but this is totally fine. This is also about differences between simulations and experiments. If you were in the lab and could try your code, sometimes maybe you could have fixed it, but yeah, it's just like this. Actually, yesterday in the night, I watched your video, and I was expecting something like the simulations, because I saw your simulation video yesterday during the day. And yeah, today in the morning, I discussed with Patrick your experiment, what's happening there. And Patrick may say something about it.
Yeah, I think you mentioned, I think you got to the, or I have the same theory as you. So you said the velocity, since you constrain the output velocity and the vehicles go above it, then the MPC fails and has this, does this stop maneuver. So yeah, I think, or we we think it's the same issue. But you also, so you made your life harder than necessary, because like you wouldn't, or we didn't ask to constrain the output velocity. So yeah, you could have just used the input constraints and we would have been happy.
Okay.
Yeah.
It is a little bit something about you wanted to have more, and yeah, maybe to do the vehicle dynamics, because it has some oscillations. It breaks the limits, and then the safety function stops the vehicle and it continues again. Yeah. So, but here you see that you can rapidly see your algorithms developed in simulations, in experiments, and you can, if you were in the lab, fix them rapidly. So the floor is open for further questions. Okay, I would suggest to continue with the presentation of Team 4.
Yeah. I will present you today with our solution. So first of all, I'd like to introduce my colleagues, Manel from France. She's working on autonomous vehicles and she's second year PhD, and Tassos at the University of Delft, and he's working on vehicle avoidance, and me myself, I'm working with MPC on HVAC system controls. And I would like to thank also to say thanks to Patrick and Professor for this wonderful course. So our graph structure, as I see, is the same as all of the previous ones. We discussed multiple ways on how to do it. Some of them would be too complicated. Some of them might have different issues. So we decided to start with the simplest one and implement that. And I can see that others had the same thinking as well. So I think that there is no need to go through it, since it's the same as the others. So a follower communicates its position to the and velocity and whatever to actually leader communicates that to the follower. In our DMPC setup, we have two different MPCs. One is for the leader of the platoon, and the other MPC is instantiated for all of the followers. We use the same vehicle model as the rest, and each vehicle model is so each vehicle is constrained with minimum and maximum target velocity and acceleration. And in a leader MPC, the goal is precise tracking of target velocity. And we have a cost function in which we set a compromise between the tracking and our control effort, which is conveniently here also a comfort metric. And in the follower optimization problem, we specify the target position for the follower, and that consists similarly as in previous solutions from the predicted position of the vehicle in front and the distance reference. And this cost function has three different performance indexes. So it's tracking of the distance, and we also want to track the target velocity. And we have to set a trade-off between these two with acceleration as well. And in this MPC, we introduced a slack variable to soften the constraint on minimum distance tracking to maintain the feasibility. So minimum distance constraint is here transferred to maximum position constraint. So we have a upper bound on the follower vehicle position. And this is often with a slack variable. So I'll first go through some simulation results in video, and then we can see the slides later. So we opted here for a more aggressive approach to get better tracking of our targets, and we compromised the comfort. It's on position tracking, velocity tracking, and had a lower weight on the acceleration. And fortunately, the experimental results resembled accurately the simulation results. So our vehicles immediately formed a platoon, and they maintain a safe distance. They do not violate the minimum distance target, and they all try to follow the target velocity. So we can compare these results conveniently between simulation and experiment, and we can see that they accurately resemble each other, with some minor differences, of course, because of the different in the experiment, the vehicles are more complex, and in simulation we have a more idealistic models. But what we can see is that in some 10 seconds we form a platoon with correct distance and maintain this distance in simulation, and similarly in the experiment as well. Our velocity targets are within the bounds, and in the simulation and the experiment, and of course the vehicles are equipped with accurate velocity tracking, so the measured velocities are also close to the commands and within the bounds. And finally, the accelerations. In simulation, all commanded accelerations are between the bounds as well, so between -1 and 0.5. And we can see here that since we have a low penalization on the acceleration, whenever the speed changes, we have almost maximum accelerations achieved. So this is not probably very comfortable, but we get good velocity tracking. And in the experiment, these commands are maintained with slight violation for some reason for vehicle 2 at one time step. But we didn't discuss with Patrick why this occurred. But all of the other vehicles in the rest of the simulation maintain their bounds. And yeah, that's it from me. Please feel free to ask your questions.
Thank you very much. Well done. It looks very nice. I have a question to the slide after the video.
Mm-hmm.
On the left-hand side, we see simulation, and you have written cost is something 48 point something, and on the right-hand side, the cost is
347.
Okay, these costs, which are you comparing? The difference is. Mm-hmm.
Yeah, I sorry for interrupting you, but this is I took a look in the morning. This is not very accurate cost calculation, so we had our own script. It's not really good calculation here for some reason. That's why the numbers do not match. I couldn't figure out why they don't match, because I have the same equation, sum of squares, but for some reason they do not match.
Yeah. Have you computed total cost in simulations?
Yeah, but again, it will not be accurate. For some reason, I don't know why.
So one difference is definitely the sampling time. So in experiment, the vehicles, for example, send data every 20 milliseconds. So we get
that
a data point every.
Yeah, because that's what that is my thinking as well. Because it's a sum of squares, it should be normalized with the number of elements to get comparable cost. But yeah.
Okay, very nice. So thank you very much to team 4 at all. Yeah, the floor is open for questions to team 4.
I have a question which is not really about the experiment, but I saw when you were working together, you made extensive use of slides to document your progress, and you created all these formulas and pictures. And I was just wondering how you did that in this quick, so little time.
So we did a presentation even yesterday, but of course we continuously updated all of these slides on ourselves. The equations are written in MATLAB, and it was easier to communicate the ideas if we have them written down than to try and explain them with speaking.
Where did you write the equations?
Yesterday, throughout the day, and so on.
I mean, with which?
MATLAB. It's an equation editor for Office. Similar to equation editor in PowerPoint, but somewhat nicer for me, at least.
Okay. Yeah. Cool. Thanks.
Maybe a further question from my side. When I visited you in your breakout session, you were always discussing. It seems to me that you were really working hard in your teamwork. Could you say somewhat about the teamwork, how you managed it, how you experienced it?
Yeah, it was really great. I mean, you're right. We were always discussing something, and especially we spent a lot of time, maybe 2 hours, discussing different structures here. How should we do them? And it was really nice to see the other ideas, and we managed it nicely without a problem. So it was really fun and really nice experience.
Okay, thank you very much. So do you have further questions to team 4?
Yeah, I have a related question, because how did you do the coding with the 3 of you? I mean, was one of you programming and the other 2 were just looking
like
at it?
This. Yeah, I basically, it was me who was programming, but we were, Tassos and Manel were looking at the code, suggesting how to do stuff, what to do, and so on.
Because before we program, we spend a relatively big time discussing. The time that it takes to program is much smaller than the time that it takes for us to discuss and to find the idea. We do like a graph and mini, like to summarize each one's idea, and we select the best one. Then it's going to be clear for us how should we proceed to write the code. Then for example, Ivan is sharing his screen and doing the code, and we are looking with him. We try to say why you don't do this, why you don't do that. It's a teamwork, and I found it really exciting and really helpful, and I really enjoyed this experience.
It was a really great, and it was a good idea to put everything on paper first, and then you just spill it out in code. It's a lot faster.
Yeah, I really like the group dynamics myself. Yeah, it was very good.
Yeah, so I once joined your group for a few minutes, and I had the same idea as Patrick and Bassam are mentioning. That's really nice. Okay,
Thank
thanks.
you.
Thank you.
Thank you very much. Actually, I haven't asked this question to teams 1 through 3. Maybe we can repeat this now. Team 1, could you say something about the teamwork?
Yes, sorry, my mouse, I can't see my mouse in Zoom, so I had to find the unmute knob. Yeah, so in our group, we decided to also focus on first trying to get a clear image of what we had to do and define, well, the objectives and what we want to put in the code. And then I was mainly coding with someone or by sharing my screen, and then there were others that were writing the exercises, and so we discussed all exercises together, but then one was writing these documents about the exercises and I was coding, and there was one looking at the code and giving comments. So that was the way we did it.
Maybe again, the same question directed to team 2.
Yeah, we did kind of the similar. Antonello was doing the coding and shared the screen, and yeah, I looked and then yeah, discuss like how to code and so on, and also yeah, check if there are any errors with the code. As for the discussion, yeah, it was quite clear in our case. Like we didn't do that much of discussion. It was quite straightforward. So we come up with an idea and we just agree to it, and then we just do the coding.
Okay. Thank you. And now team 3.
Yes, so we also didn't discuss quite a lot because we opted for one of the more simpler solutions. So yes, I was doing most of the coding. Joy was writing down the exercises, so she was also really extremely useful while debugging. She spotted a lot of errors that I left, so I think it worked quite well for us.
Thank you very much for the presentations and for answering the questions. And yeah, I would suggest that we now move on to the presentation of team 5.
We are, my teammate is Mateus Pedrosa from Brazil. He's studying on computer science and automotive and control engineering. And I study on control. The other some things, presentations were really well suited, and I really appreciate their work. However, our presentation is not so comprehensive. This is because of that. Mostly my teammate had to study himself because I encountered so many problems related with MATLAB VBS support package, VBS block set, etc. So we could finally manage to work together at the last 2 days. So because of the limited time, we skipped the communication via the IDEA language. We just chose to proceed by using the local information of predicted output by the NPC. And so just as in the centralized MPC example, we use the distance value between two adjacent vehicles. Our approach is very simple. The vehicle with the highest index has the highest priority. So vehicle 5 needs the information only of vehicle 7, and vehicle 3 needs the information of vehicle 5 to calculate the distance between itself. We somehow modified the centralized MPC file so as to include a reference trajectory for vehicle 7, which is the highest priority vehicle, and the others were the same as the centralized MPC case, but we partitioned into individual cars. So each individual car performed its own MPC optimization, and it's produced its own control input. We first make in the first simulation we did we just skip the detail which we could not recognize at that moment. While we are when we give the highest priority vehicle a reference trajectory, and as you may remember, there's an error penalizer queue for the output error penalizing in the MPC formulation. We just forgot to make it 0. So our highest priority vehicle tried to perform a trajectory generation, and its predicted outputs are used within the rest of the vehicle's MPC formulations by making a distance between the predicted output with a distance of direct, which is equal to 0.5 meters. However, the highest priority vehicle did not need a reference trajectory to follow. So we encountered such a situation that our car 7 followed the reference trajectory, which was defined in the main MPC file, 1.1 plus 0.1 sine t. So it's something sinusoidal wave on a step function of value 1.1. So our reference velocity profile was not consistent with this displacement, because velocity is the derivative of the displacement. So our MPC produced somehow a velocity output, somehow a derivative of our reference trajectory that we wanted car 7 to follow. So the results were, I think, not good. However, our codes were run in the experiment in the lab, and the cars managed to follow the platoon shape within, but with one detail that I will talk about later. Then we made our modification to our code by asking Patrick, and we made the corresponding coefficient of Q coefficient of vehicle 7 0, so it would not follow the trajectory anymore. The only thing that we wanted car 7 to follow is the velocity profile, and the other cars, we want other cars to follow the distance between the between its neighbor vehicle with higher priority. You see now the last simulation results here, and this is the distance between pairs of vehicles, which we know we want that it should be at a value of 0.5 meters. Vehicles somehow deviate from that distance. And as I said before, in the first simulation, our velocity profile, because of the sinusoidal turn in the reference trajectory that vehicle 7, the highest priority vehicle, was following, the velocity profiles like that, my mouse cursor's movement, the sinusoidal wave, which is caused by the sinusoidal component in the disturbance. So our velocity profile could not follow this reference trajectory. Then we made the correction to our code, as I explained. Then the input velocity over time just got closer to the desired velocity profile. Similarly, output velocity of the vehicles could follow within some range the desired velocity profile. And this is the input acceleration over time, which is the change of the input velocity. And the cars try to keep its acceleration as close as possible to zero. So it tries to keep its extent small. Now you see the video of the experiment in the lab. Just let me indicate that this was the experiment of by using the code of the first simulation of the first code that we wrote. So you will see in the beginning the highest priority car here will wait for other cars. Will follow its trajectory. So there is something interesting in that video. You will notice it. So in this presentation, I indicate the difference between two different approaches. Which was the first approach was a little had a little error in the strategy. Now I'm running the video. This is the highest priority vehicle. As you see, it waits for other cars because we accidentally did not provide a non-zero penalizer value for its velocity profile tracking in the MPC formulation. So it couldn't follow the velocity profile from the beginning. Nevertheless, the code ran anyway.
Thank you very much. Yeah, it worked at the end. And yeah, this is due to, let's say, deadline working. So Adam worked yesterday till the night to get it running. So I like it if people stick to the problems till they get a solution. So I may ask question to the figure with the distances. Maybe it's number 3. Yeah, I see here an objective value of 131.51, right? Which one is this? Is it the one computed by Patrick?
This is the one computed by a simulation, lab control center.
Okay. And do we have one computed from the lab?
Let me look at. Must be.
Yes, I found one, right? So it is in the figure in your share in folder.
Yeah.
Okay. Yeah. Thank you very much. So the floor is open for questions.
What was your explanation that the highest priority vehicle waits for the others?
In the first code that we wrote, since we copied some parts from the main MPC, which was for one vehicle, we were interested only in its trajectory following, but we were not interested in velocity in any way. So we just skipped the detail that the canalizer matrix Q, its corresponding row, which is second row, corresponding row to the velocity tracking, was zero, was set as zero. So the highest priority vehicle was not supposed to be tracking the desired velocity profile. It was only interested in the reference trajectory, 1.1 plus 0.15 sine t trajectory like this. The other cars were interested in keeping the distance between themselves. So at the beginning, the car waited, the highest priority car waited for them, the other cars to come to it, because if it moved, the distance which is initially more than 0.5 meters could grow larger. So it waited for others to come near to it. And then it started to follow its desired trajectory. That's an interesting situation which we encountered accidentally.
But the vehicle with highest priority doesn't have like this reference distance to other vehicles in its objective function, right? It just follows a given, like as you said, the trajectory from the first exercise sheet. So my guess would be that the trajectory it should follow just starts behind it, and then at some point the trajectory it should, or the position it should follow, catches up with the car, and then it starts to follow it, and that the others and it just coincidentally looks like it's waiting. So I think like saying it's waiting kind of implies that it cares about the other vehicles, but I think this is a bit misleading.
And I have one question about vehicle number 2, because if you start the simulation, vehicle number 2 will start moving, and it has a large distance between vehicle number 2 and 3. It will start moving, and then it will stop until the rest of the vehicles, apparently it looks like this, the rest of the vehicles reach it, and then it will follow again toward the vehicle 1. Can you run it just one more time? So I don't know what's happened, but the vehicle number 2 also kind of started for a while and then stopped, and then joined when the other vehicles joined it, it moves toward the vehicle number 1.
Yeah, as you mentioned, that's kind of interesting. Also, as Patrick said, vehicle number 1 has nothing to do, such as keeping distance with the vehicle number 2 or the car following itself, but in any way, it waited for the other car to come. For the moment, I cannot explain it detailedly, because the second car tried to decrease the distance between itself and the leader. However, it also took into consideration the other cars, so at some point it got slower to wait for the others to reach it. So that's, as you said, that's something interesting. Yeah.
I have a related question. Is it maybe related to the figure that you showed before with the communication graph? So I guess on your second slide, I see the arrows pointing. Oh, wait, okay, no, never mind. Vehicle 7 is on the right side. So on the right has highest priority, I assume.
Yeah, vehicle 7, 5, 3, the same order is seen in the pattern of these vehicles, 7, 5, 3, 2, 1.
Yeah, I just thought maybe you're defining the communication the other way and therefore they are waiting for each other, but I don't think that applies here. Okay.
I guess maybe something related with the in the lab environment at the time of experiment was taken was being realized. The communication between the cars, maybe there was something related with the communication or at some steps, which is caused by the non-ideal case of the real life related when compared to the simulation. I don't know why exactly for now.
Well, thank you very much. I would now suggest to move on to the presentation of team number 6. So please, the floor is yours.
So that would be us. So I hope it's working. No? Yeah. Okay. Yeah. So we are team number 6, former team 7, but we identified with team 7, so I just stick with that number. Team 7. These are Berat, Bikash, and myself, Maximilian. Berat has a background in computer science, but more on the communication side. He's actually not pretty new to automatic control, but in the early stages, I would say. Bikash also has a background on automatic control, and is pretty experienced. And I coming from flight systems with a little bit of experience in automatic control. So actually a pretty heterogeneous team, I would say. And this was what we already, or what we saw also in teamwork. So did many different ideas, many different perspectives, and we also did some deadline work in the end because we had a couple of problems with starting everything with time management and then getting into the code. So in the end, we had 2 vehicles in the lab working. We managed to extend the code this morning and also to create a little extra feature to maybe get the bonus points to compensate for only the 2 vehicles in the real world simulation. But first of all, about the graph structure with the priorities. We also managed to get 5 vehicles to run, at least in the simulation. And we decoupled the instantiation of each vehicle with its priority. So we decoupled this, we made these 2 steps so that we can, during execution of the main control loop, change the priority. We did it manually, so in response to the time, so after a while, the priority is changing. But it can also be adaptive, for example, if a sensor is triggering a message, or I immediately thought of something like implementing visual flight rules, or when you are at the intersection, for example, that the one who's right of you has the higher priority. So something like this, we played around a little bit. But for the main modeling or the main approach we did to solve the exercises, it was just like all the others. We also did this chain view here. So the first one is talking to the second one, and we had a reference input on the same output from vehicle 1, just minus the difference D, and then propagating this to the end of the platoon. Of course, as the platoon gets longer, this will become unstable or kind of unstable, but this was the first approach we agreed on, and then we just went through it. The results are not that interesting due to we had only 2 vehicles, and unfortunately we switched the numbers of the vehicle. So Patrick was so nice to put vehicle 2 first, vehicle 1 first and then vehicle 2, but therefore the distance here is with the wrong sign. So I guess the tracking here is It's pretty good because we only had one vehicle here. Yeah, so nothing special also really here. We had actually pretty good tracking. Also due to time limits, we also couldn't manage to really tune the MPC here or to yeah, make anything great out of it. So as you can see here, maybe for the quick tracking here, you can see that due to vehicle dynamics, we're already at the limit for the acceleration here. Maybe you can change this also by extending a little bit the control horizon to track earlier, but I guess that's I guess maybe the maximum it can get for reference tracking, at least for velocity. Okay, so the video is also not that spectacular. So the two vehicles here. So what I like that it's pretty quickly coming into the platoon, the second one, that's not waiting that much. So the tracking therefore is first shot, pretty good. And yeah, so not that special. Okay, but I want to show you maybe the simulation of the dynamic priorities. I hope that this works. So, let's just wait for the connection. Oh, maybe click deploy. Problem is that when Zoom is running, there are already many resources taken from my computer. So I hope this does not have any effects on the main control loop. Come on. Okay, maybe I'll start over with the LCC. So for the idea of the priority changing, maybe I can elaborate on that. It's pretty easy because just the first vehicle, like you all already told, has different reference tracking than the other vehicles, so the vehicles following. And we kind of incorporated that by setting the weight on the matrix G, so the first entry, to 0 if we are calculating MPC for the first vehicle, and after that we are setting it back to I guess it was 100 or something like this, so that the following vehicles are caring a lot about the distance tracking to the leader vehicle. 1, 2, 3, 4, 5. Deploy. Okay, looks good. Once again. Sorry for the waiting.
It's fine. We are interested to hear the results.
Oh man, I'm building up pressure right now. No, it's not just as I said. So we have not tuned anything. We had not compensated for code optimality or something like this. We just played around a little bit to try to get some bonus points. Oh, this should be 400. Can I edit it while execution?
It should, be possible.
Okay. Let's see.
Let's see. I never tried.
Looks good, actually. MATLAB's also not complaining. No. Okay, let's see. So, yeah, okay. So of course they are overlapping because we for the overtaking scenario, so for the changing in priority, we had to lower the constraints on each vehicle so that they can overcome. So okay, you see this kind of unstable behavior here. I'm not sure if this is due to package dropping, because as I said, Zoom is taking a lot of resources, because as I did it without Zoom, it's working. But you see that they are changing positions. So we started with 5 in the beginning, now it's 1 the leading vehicle, and yes, now they should stop. So you see, I've totally changed the order of it 2 times during execution, one at 20 seconds and 1 time at 30 seconds, while also having the velocity profile driven through. And yeah, of course, the performance of the controller was not really good. I wouldn't be a passenger in the vehicle, but it's yeah, it's just a proof of concept of dynamic priority assignment. Okay, thanks. That's it.
Thank you very much. This is very creative with the dynamic priority assignment. And you're right, it is due to maybe Zoom, because if the virtual machine doesn't receive enough power from your computer, then some packages are missing and you get this weird behavior. So it is not due to your code. Actually, I didn't get it 100% why you are changing the priorities. I mean, changing priorities is something, is a good idea for some goals, but in your case, I didn't get it 100%.
Okay, yeah, so maybe to say, if I have a situation where, or just take normal streets, so for an intersection, it might be good to say, okay, the vehicle which is right from me has higher priority, and then change the priority of all the vehicles at the intersection depending on how the situation is, so on how many vehicles are there. And I know, so my idea at first was because there are some visual flight rules. If you're in a cockpit and you're flying and you see, for example, someone also coming from the right, you have to, for example, descent, I think. So yeah, just implementing something like this, and yeah, just a quick idea.
One more thing is that maybe, for example, in autonomous systems, if they have different capabilities at each scenario, each time, maybe one of them should take the lead. So due to their capabilities. So that can be one scenario. And also, I think Maxime and since we were mostly working on the aircraft or submarines and this stuff, it was completely okay for us to go over each other. So the cars just sometimes moved over each other. But that's
a nice explanation. Yeah, in underwater and in the air, it is possible. So I would accept this explanation. Yeah, and again, it's really creative. So I would open the floor for further questions towards Team 6.
Can I ask one?
Yeah,
if you go to the slide, the first slide showing some results, I guess.
These two?
Yeah, this one.
Yeah.
Can you explain why the objective function value is so high?
That's actually a good question. So I have to admit that just during presenting the slides, I recognize this and also had it in the back of my mind. I guess maybe it's due to the wrong sign. So you see that the ref is this. Oh, does this make any sense?
I mean, maybe did you put high numbers in your penalizing matrices or something?
Yeah, this could be the case. Yeah. So we played around a little bit to like tuning and just tried some different weights. This could be a good explanation. Yeah, actually yes.
And what numbers did you put?
I guess we penalized errors on the distance tracking by 1,000 or maybe even more.
Okay. Yeah.
Yeah. No, good. Yeah, I hadn't it in my mind. Thanks.
But,
Yeah.
oh, sorry.
Yeah, I was just wondering why these numbers are so high. But maybe they're. I mean, it also depends on how you define your objective function. So, yeah. Okay. Thanks.
But if I may add to this, so I think all this cost values generated from this automatic plot function, which expects the vehicles to be in the other way around. So yeah, they always have an error of, I don't know, minus 0.5 to 0.3, so 0.8. And then there are these large jumps whenever they complete a lap. So there's the lap distance added, and in the squared error, these will be heavy. So yeah, so I think it's due to that.
Maybe this could be related with the change of velocity. I don't know. I'm just guessing from the time. So when some velocity changes, we have these peaks.
I have a question concerning the dynamic priority assignment.
Mm-hmm.
I didn't get well, how could the leader be changed? I mean, based on...
Yeah, so I could maybe show you, this is the most easy way. So at first, the vehicles, of course, are instantiated before executing the main control loop. So we're saying here, okay, each vehicle is getting these constraints and these parameters actually. And then we say, okay, priority 1, so the highest priority has vehicle number 5. Priority 2 has vehicle number 4. Priority 3 has vehicle number 3. So just like this. And if so this is a step of decoupling actually. So in the control loop, I can just say, okay, if your time is bigger than 20, I can just rearrange them. And to get this going, the reference generation here has to depend on not the vehicle, but on the vehicle with the highest priority. Yeah. So this it's just adding the step of decoupling, and then I can change whatever I want.
So the change of the priorities is, I can say, you change. It's you that you put it, and you tune it based on the time. It's not, for example, based on a distance traveled or something that is done automatically. I mean, like.
Not yet, but you can just, for example, here add the vehicle 1.s bigger than 50 or bigger than 2. I don't know, as you like it. And what I mentioned earlier was that, for example, you can say, okay, if vehicle 2 is too close to vehicle 1 or something, so you can make it really, really adaptive.
Okay, thank you. Nice idea.
Thank you.
Oh yes, I mean, changing priorities and distributing priorities could be a PhD thesis. So if you would like to do it, just contact me and we can discuss it in more details. So thank you very much for the presentations. Maybe a general question, we will discuss if we put the course, because we recorded everything on YouTube. If you don't agree to put your presentation now of the lab work on YouTube, let us know. Or if you want your sound or your picture cut from certain video, just let us know. We will put the videos before uploading to YouTube, also on the share out, so or share in, I'm not sure. I think the share out, so you can check if you want to not have something there. So I limited the time of the share out. Maybe I'll extend it till we prepare the videos. Right, and now I have a question to you. How got you to know about the course? If you got to know about the course from the website or from the program of EECI, then it's fine. If not, could you tell me just if you have got the knowledge from other sources? So all of you got to know about the course from the EECI website?
For me, it was my supervisor who pointed EECI out, and then I went through the list, and then I saw this course and I found it interesting. So,
okay.
Even me, same for me. It was my supervisor that sent us the links, and he told us if you are interested to one of the modules presented here, you can only tell me, and I will do the necessary. So I saw that course and I was interested in, so I contacted him back, and that's it.
Okay, thank you very much. So, and yeah, now I would like you to evaluate this course. I have two evaluations. One is for the EECI. I'll send you now the link and the password. There you have to choose the module. So this evaluation is for all courses, and you have to choose the right course. And the next one I'll put there is for our university. So it is a lot to evaluate, but we'll give you the time for this because Patrick and I will leave for some minutes to discuss about your lab work and to decide also on the best solution. And yeah, we will prepare the farewell and we will get back to you. And if you have further feedback for us and further evaluation, oral or written, just let us know. We will be happy and we appreciate your feedback. So I would be happy if you would do both of the evaluations. So now Patrick and I will leave this meeting. So you would stay just here. You can have also, after the evaluations, some chat with each other, maybe grab a coffee for the remaining of the day. So we will get back in, I don't know, 10, 15 minutes. So see you later. Sorry, I'm back again. So now it's time to for farewell, right? So I'll share my screen. So do you see my slides?
Yeah.
Okay, very nice. So first of all, I enjoyed the course really very much. It was one of my best courses with a very nice group. So I hope to see you again somewhere physically also. And yeah, this is the picture of the group. Yeah. Here we see now Patrick. Before we continue, we should give a big applause for Patrick. He was the man behind the scene before the course and during the course. He was the whole time during the course, he worked till the night. For example, yesterday to get your experiments running in the lab. And also today, He came early in the morning and prepared everything. So I would like to thank him very much, and maybe you would like to turn on your microphone and give the applause.
Oh,
Thank you.
Thank you.
Thank you very much.
Thanks, Patrick.
So this was our schedule from the beginning. On Monday, we met. We started with the introduction. We introduced vehicle models. It was a little bit new for some of you, a little bit old for others. Patrick introduced the architectures, especially in relation to the lab, and you started working with the lab on the basics. Maybe in the beginning, it was sometimes easy, sometimes hard to get into the setup. Maybe you didn't know what is expecting you on Friday. So on Tuesday, we continued with MPC. You continued after implementing or working on the basics of the lab. And in the afternoon, I introduced the network stuff to you, and you started implementing real stuff in the lab using CMPC. On the next day, it was an exciting session in the morning. Actually, this is not the final program. We spent the morning discussing the network topics, and you continued in the afternoon implementing the CMPC. On Thursday, yesterday, you were working really hard to get the code running in the lab. And today I continued explaining the optimization, and we enjoyed your presentations, and now we are getting close to the farewell. But before the farewell, special thing in this course, and could just be realized because you are a nice group, because I know digital social event is hard to realize, but we managed to do it, and maybe we just take a look at what happened in the social event. And thank you, Joy, also for this game. It was very exciting, and we laughed a lot, and it got us really together, this game. And this game also shows how in a network, also if we work sequentially, that we have outdated knowledge, or we don't have here the knowledge about the previous drawing or finding of the sentences. So it was really, really nice. And
I may upload the rest of the trips, maybe, for everyone.
Yeah. Yeah, in the introduction on Monday, I told you that I'm going to donate 15 euros per working solution for a good cause. On Monday, we had in the morning 7 teams. We reduced the teams to 6, but actually I'm going to donate 105 euros, 15 euros, because something between Patrick and me. So, I said the best solution will be invited to spend a week with us here, maybe you will manage to, the winning team will manage to come together, then you can meet also physically. Of course, all of you are invited to visit us physically and to experiment in the lab and yeah, to get to know us in real. I will also try, if you email me, to get some funding for you for your visit if you would like. Of course, visits longer than 1 week are also possible, maybe to spend a research semester or research months in our lab are possible. Yeah, in general about the teams. So if I may summarize, so team 1 worked really hard yesterday to get to a solution. And when I went home yesterday at 6, I thought, okay, yeah, I was excited if team 1 will do it. And I was really surprised that you have managed to do it completely. And the communication structure in your solution is really impressive, that you thought also to communicate from the leader to the other vehicles. So this is really creative. So team 2 was very efficient. I think you are very good at programming, and they managed to finish the DMPC implementation yesterday at, I think, 2-3 p.m. So they came over to the main room and they told me, okay, we don't have questions, but we finished. What should we now do? So I was surprised, whoa, what should I tell them now? And I was happy that Patrick has already provided some extensions. Actually, the same is for team 3. They were also very fast, very efficient. They had the solution also, I think, yesterday at 2 or 3 p.m. And they were also discussing, okay, what can we do? And I was again very happy that we have thought about some extensions. Yeah, and your simulation results are really nice. So for the experiments, it is an experience that experiments deviate from simulations. So team 4 were very dynamic. They worked really hard, and they wanted to get the cost values. They wanted to get lower cost values. So as you heard in their presentation about the dynamics in their team, it was really exciting, and they got really nice results. Yeah, and for team 5, I think you learned a lot, and the idea of changing the priorities, that the highest priority agent is in the back of the platoon, is very creative, and we can call it inverse platoon maybe. And yeah, it is actually also creative for autonomous driving. I mean, a simple example, assume that you are cycling and you want to transport things, and you want to see them in front of you, and you can have a small size vehicle where you can put the heavy stuff on it, and it drives in front of you, and you can follow. So it is a very creative idea. So for team number 6, I mentioned it during the Q&A session after the presentation. I think it's a really nice idea to have dynamic priorities, and I really think this could be a really nice research topic. So as you maybe heard on the last slide, I will spend 105 euros for a good cause, and you noticed that challenge. All of you won that challenge, and yeah, I'm happy to do that. But despite of that, we had to decide on a winning team. I mean, all of you won, but we have to decide, let me say, on the best solution. And actually, it was not easy. It was a neck-to-neck race, and we were not sure which solution should we choose for the best solution. But then we decided to rely on the numbers, and he is the winning team. So also big applause. Maybe you turn on your microphone. So well done, team 4, and I will be very happy to try to contribute to your visit to Aachen if you could manage it. So tell me, and I'll be happy. So just an information about the certificates, you will receive them via email, not email, via mail from EECI. I think mail, as they told me. I don't know if it's going to be a scan via mail. So I'll stop my screen sharing because now I can see all of you on my screen. So it was very nice, but nice times end also. So hope to see you, and see you maybe on a conference or in Aachen. Patrick may say bye. Bye.
Yeah, I already said it was really nice to meet you. And goodbye, enjoy your weekend, you earned it.
Thank you very much.
Thank you for this week.
Thank you for the week. Yeah, it was very nice.
Yeah.
Thank you. It was very nice. Bye.
Thank you.
Thank you, guys. Bye.
Thanks, everyone. It was very nice.
Bye.
Bye-bye.
Bye, everybody.
Thanks for this amazing win. Thank you for everything. Hope to
Thank
meet you in real life.
We enjoyed it with you also. So bye-bye.
Bye.
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 Bye bye.